So let's just move on to what the question number 2, which says that find the HCF and the LCM of the following pairs of the integer and verify that LCM into HCF is equal to the product of the two numbers. So let's just start finding out the HCF as well as the LCM of the pairs of the integer. So let us suppose we are talking about the part number 1, in which we have to find the HCF and LCM of both the numbers 26 and 91, and the second part is 510 and 92. So let's just start with the first part, and we have to find out the HCF as well as the LCM. So let us suppose I am finding out the HCF and the LCM using the prime factorization method. So let us suppose we are talking about the number 26 first. So the answer of it will be like, let us suppose we are finding out the factors of 26 first. So if I'm talking about the factors of 26, so let us suppose I'm dividing the two parts in this section. So let's just start finding out the factors of the 26. So if I'll take the LCM, then it will be like 2, 1 and 3 and 13 and 1. So the factors of 26 are actually 2 and 13 only. And furthermore, if we'll talk about the 91 number, so the factors of the 91 would be like 9 and 1. So let us suppose I'm talking about taking the LCM of it. So it will be like a 7 into 1 is 7. So 2 is nothing but the remainder. So 7 into 3 is 21. So it is 13 and again 1. So the factors of it are like 7 into 13. So let's just talk about finding out the HCF and the LCM of these two numbers. So first of all, the HCF of 26 and 91. What is the meaning of HCF? HCF means the highest common factor which is among these two. So we know that the highest common factor both of them have is nothing but 13 raised to the power 1. So this is nothing but called as the HCF of these two numbers. Now move on toward the LCM. Of 26 and 91. So what is the LCM of 26 and 91? So it involves the number 2, it involves the number 2, it involves the number 7, and it involves the number 13. So the LCM means the least common factor which is in both these numbers. So the least common factors are basically 2, 13 and 7. So it is 2 into 7 into 13. So it will be nothing but, let us suppose I'm multiplying both of these, it is 14 into 13. So let's just multiply 14 and 13. So it is nothing but 12, it is nothing but 4, it is 4, 1, so it is 182. So this is nothing but is equal to 182. So let us suppose I'm talking about finding out the HCF of these two numbers and the LCM of these two numbers. So obviously the HCF is nothing but 13 and the LCM is nothing but 182. So at the end, HCF into LCM means we have to verify that the HCF and the LCM of these two numbers are actually these numbers again. So let us suppose I'm multiplying these two numbers and we have it as equation number 1. Let us suppose I'm taking it as equation number 2. So I'm multiplying both these numbers together. So HCF is 13 and the LCM is nothing but 182. And we have to find out that the HCF into LCM is nothing but is equal to the product of the two numbers again. So let us suppose I am taking 2 from 182. So we can write it as well like a 13 into 2 into 91. It can be written as 2 into 91. So this will be nothing but is equal to 26 into 91. So it is all clear because the number 26 and 91 are those numbers again which are actually given to us. So it means that the HCF into LCM of the two numbers is always is equal to the product of the two numbers from this particular part. So the HCF and the LCM, I guess, is all clear to you that how we can find the HCF and the LCM using the prime factors or using the factorization of the two numbers. And furthermore, from this particular concept, it is all clear to us that the HCF into LCM is actually nothing but the product of the two numbers again. So let's just move on further towards this particular part. So first of all, we will take out the LCM of 510, and with the help of the LCM we can find out the factors of 510. So let us suppose I'm dividing it with the number 2. Let us suppose I'm taking 2. So it is 2 into 2, which is 4. So 1 will be the remainder. So 2 into 5 is 10. 1 will be the remainder. 2 into 5 is 10. Again we can divide it with the number 5. So 5 into 5 is 25, and 5 into 1 is 5. Again we can divide it with the number 3. So 3 into 1 is 3. The remainder will be 2. 3 into 7 is 21, so 17 into 1. So the prime factors of 510 is nothing but 2 into 5 into 3 into 17. Furthermore, we can find out the factors of the 92 as well. So let us suppose I'm taking out the LCM of 92. So it is 2 into 4 is 8, 1, 2, 6 into 12. So it is 2 into 2, 4, 2 into 3 is 6. 23 obviously is a prime number. So we get the answer as 2 into 2 into 23. So we can write it as well, 2 raised to the power 2 into 23. So this is nothing but the factors of 92, which are nothing but 2 square into 23. So let us suppose I'm talking about the HCF of the numbers 510 and 92. So it is nothing but the product of the factors. So basically it involves the product of the factors. It involves the product of the factors, the product of the common factors. Let us suppose I'm talking about finding out the common factors, product of the common factors with least powers. With the least powers. So let us suppose I'm talking about finding out the HCF of these two numbers. So this one is my first equation. Let us suppose this one is my second equation. So first of all, in the first number and in the second number, we do know there is one thing common, that is nothing but a number 2. So HCF means a product of the common factor with the least power. We know that the least power of 2 and 2 square is obviously 2 raised to the power 1. So the number or the HCF or the common factor, the very first common factor is nothing but 2 raised to the power 1, because we wanted to take out the HCF, and HCF always means the product of the common factors with the least power or with the smallest power, we can say. So the very first common factor is nothing but 2 raised to the power 1. Furthermore, we have nothing in common in between these two. So this is nothing but the highest common factor of these two numbers. And what is the meaning of the least common factor? It is actually the opposite of the HCF. So let us suppose I'm talking about the LCM of the two numbers. So it means that, or it says that the product of the common factors with the highest power, the product of the common factors, or we can say the product of the factors. We cannot say about the common factors in the case of the LCM. In the case of LCM, we'll talk about taking the product of all the factors with the highest power only. So the LCM of these two numbers will be like 2 raised to the power 2 is the common one, 2 raised to the power 2 is the common one, and they do have a highest factor as 2. So 2 raised to the power 2, and other factors as it is, we can take the multiplication of other factors as it is. So it will be like 5 into 3 into 17 into 23. So this is like a 2 raised to the power 2 into 5 into 3 into 17 into of 23. So this is my answer. So let us suppose I'm not solving it, because at the end we just have to prove that the LCM into HCF is nothing but is equal to the product of two numbers. So let us suppose I'm taking it as the equation number 3. Again, we have to prove that the HCF into LCM is nothing but the product of the two numbers. So let us suppose I'm taking the HCF over here. Let us suppose I'm calling it as equation number 4. So let us suppose HCF is 2. So HCF is 2, and the LCM was like 2 raised to the power 2 into 5 into 3 into 17 into 23. So let us suppose I'm solving it in such a way that I should definitely get the answer as 510 into 92. So first of all, in 510 we do have the factors as 5, 3, or we can say 2, 5, 3, 17, because we know that 510 do involve the factors as 2, 5, 3, 17. So let us suppose I'm combining 2, 5, 3, 17. So 2, 5, 3, 17 means 510. So let us suppose I am taking the multiplication of the one which do have a pink tick above all of them. So they are nothing but 510. So the remaining elements are 2 raised to the power 2 and 23. 2 raised to the power 2 and 23. So we do know that in the equation number 2, 2 raised to the power 2 into 23 is actually 92. So 2 raised to the power 2 into 23 is 92. So it is nothing but is equal to 92. So hence at the end the answer is that the HCF into LCM is actually equal to the product of the two numbers again. So this is all about finding out the HCF and the LCM of the two numbers using the prime factorization method. And at the end of each part, we have proved that the HCF into LCM is actually equal to the product of the two numbers. I hope the concept is all clear to you. So let's just move on further.